Hello and oh 07 fellow gamers, I'm Swap Gaming, and today we're diving into the fascinating world of game persistency. Ever wonder how to maintain game progress across sessions to enable player interactions like item trading in a shared store across different instances? Simply saving data locally won't cut it for connecting players from varied sessions. In today's multiplayer and shared game environments, external data storage is key. This ensures that all players can access consistent and secure information outside their individual game sessions. Enter the role of databases, hosted on servers to keep player information and in-game items available and current for everyone. But how exactly do these components, your game client, REST APIs, and databases intertwine to create a seamless and interactive player experience? That is our focus today. We'll guide you through how these elements interact, delve into how APIs function, examine various types of databases along with their benefits and shortcomings, and discuss the security vulnerabilities that could arise. This exploration aims to provide a comprehensive understanding essential for crafting engaging and secure games. Now you might wonder, must I be a web developer as well as a game programmer? No, not exactly. A basic grasp of web tech and databases is essential, yet mastering just the fundamentals can already set you on the right path. And yes, when advanced into production, having a server or web developer review your setup can be crucial to ensure everything is secure, efficient, and ready for launch. So whether you're flying solo or working in a team, this video aims to elevate your understanding and help push your game development forward. Let's unravel these technical mysteries together and arm you with the knowledge to build the game of your dreams with a robust, scalable backend. Now that we set the stage, let's dive into the components that make online gaming experience possible. We're talking about three main elements: the game client, the API or application programming interface, and the database. First up is the game client. This is essentially the game itself that you play on your computer or console. It's your portal into the gaming world. In a purely single-player offline setting, all necessary information such as high scores and inventory items can be stored locally within the game client itself. This is often managed through regular save files. However, the situation evolves as we introduce the concept of different sessions. This could mean different play sessions for a single player, or interactions among multiple players in an online environment. If we want data like high scores, player progress, or store inventories to be consistent and accessible no matter when or where the game is played, the local storage approach falls short. This data must be stored outside the local game client, typically on a server. This shift from local to server storage means that a game client needs to communicate with a server to retrieve and update data. This ensures that a player returning to the game or a new player joining a multiplayer game will have access to the most current and consistent information. This seamless synchronization between different game sessions, crucial for maintaining a unified gaming experience, is enabled through the use of APIs and databases. So this is where the API comes in. Think of the API as a middleman or translator between your game and the database. It takes requests from your game, like saving a high score or retrieving the latest player data, and communicates these to the database in a secure way. And then we have the database. This is where the game data is stored. It can be anything from player profiles, game stats, to the items in your in-game store. The database ensures that this data is stored safely and can be retrieved and updated as needed. So how does this all work together? Let's break it down. When you perform an action in the game, like completing a level, the game client sends a request to the API. But how is this request sent? It uses what we call the HTTP protocol. It stands for Hypertext Transfer Protocol. This is the foundation for any data exchange on the web, essentially the language that computers use to talk to each other over the internet. Once the game client sends the HTTP request, the API receives and interprets it. Think of the API as a bilingual translator that understands both HTTP and the language of the database. The API then translates and directs the request to the database, which processes the information and updates your progress. But we're not done yet. The database sends the updated data back to the API, again using HTTP. The API translates this into a format your game client understands and sends it back to your game, showing you the new high score or level completion. In this way, HTTP acts as the backbone for communication in the gaming world, ensuring your achievements are recognized and stored correctly. But what happens when millions of players are doing the same?
The API managed requests from all these game clients simultaneously, ensuring that each player's data is accurately updated and retrieved from the database. This system allows for scalability, managing an increased number of players without sacrificing performance or security. The combination of game client, API, and database allows for a dynamic and interconnected gaming experience. While you might not need to become a web developer to create your game, understanding how these components work together will help you design better and more engaging games. Alright, so let's move back a step. Imagine dining at a restaurant. Instead of heading straight to the kitchen, you communicate your order through a waiter. In digital terms, an API, application programming interface. He acts like a waiter. It's a crucial messenger, conveying your game's request to the database and bringing back the needed information. But it's not just about passing messages. It's about doing it safely and correctly, ensuring that the data exchange doesn't harm the system. In game development, REST APIs or representational state transfer APIs are indispensable, particularly in environments like Unreal Engine. These APIs function under a set of guidelines that simplify the communications, akin to the etiquette a waiter follows. They are the bridge connecting your game to its database, allowing secure and efficient exchange of data, be it the player score, progress tracking, or facilitate multiplayer sessions. REST APIs manage these data exchanges via the internet, streamlining interactions between your game clients and servers, thus ensuring a consistent and engaging player experience. When your game needs to fetch or modify player data, it sends a request through the REST API using the HTTP protocol. The API understands both your game's needs and the database language, processes this request, it retrieves and updates the necessary data in the database and then relays it back to your game, all in real time. This seamless process is what keeps the gaming experience fluid and dynamic. Let's look at why we need an API and not just connect the game client straight into the database. Directly connecting your game to the database might seem straightforward, but exposes your system to numerous risks. This method is like having a door from your house straight to a bank vault. It's convenient, but extremely unsafe. It opens up vulnerabilities where hackers can exploit your game, manipulate data, or cause performance issues, not to mention legal and compliance headaches. Moreover, as the game scales, a direct connection can overwhelm your database, leading to performance bottlenecks and potential service outages. Therefore, leveraging REST APIs is more than best practice. It's a shield that protects your game's integrity, performance, and legality. Utilizing server-side APIs offers a robust alternative to direct connections. They act as a secure intermediaries, ensuring data integrity, player fairness, and system scalability. By adopting this approach, you safeguard your game from security threats, performance issues, and legal challenges, all while providing an optimized gaming experience. To sum up, while direct connections offer simplicity, they fall short in security, scalability, and compliance. REST APIs fills this gap, enabling safe, efficient, and scalable interaction between your game and its database. By understanding and implementing REST APIs, you ensure your game remains secure, performant, and ahead of the curve, providing a seamless experience for your players. So where are the API located? The answer is straightforward yet fundamental. The API typically resides on a secure server. Now you might wonder, what about the creation of these APIs? Well, APIs can be developed in a myriad of programming languages, providing the developer with the flexibility to choose the one that best aligns with their project needs or their own expertise. Whether it's Python for its simplicity, Java for its robustness, or JavaScript for its prevalence in web development, each language offers unique benefits. This diversity in programming languages allows APIs to be tailored to the specific requirements of the game. So the API housed in a secure server is not just a bridge, but also a customizable tool molded by the language it's programmed in to best serve the game's architecture and design philosophy. In my experience, I find using Node.js with Express.js particularly effective for building APIs. Node.js is built on JavaScript, which is accessible and widely adopted, plus Express.js, a framework for Node.js, simplifies the API creation process even further. The power of Node.js combined with Express.js lies in their efficiency and the vast ecosystem. There are countless modules and tools available, making API development quicker, better scalability, and more flexible. Understanding APIs and how to build them is crucial in today's interconnected digital landscape. They allow your application to communicate with each other, share data, and extend functionalities. Now that we understand APIs, let's move on to another crucial component, databases. What is a database? Think of a database like a digital filing cabinet where you store and manage your data. This can be anything from your contact list on your phone to inventory records for a business. But how do we interact with its data? Well, we use something called queries. A query is a request for data or an action to be performed on the data in the database. It can be as simple as asking the database for a list of high scores, or as complex as updating inventory levels based on recent transactions. These queries allow us to retrieve, insert, modify, or delete data, depending on our needs. However, it's crucial that these queries are well managed. Poorly designed queries can lead to slow performance or incorrect data, impacting the overall functionality and reliability of your game. There are two main formats of databases. There are SQL and NoSQL. SQL, that stands for Structured Query Language, is a type of database that uses structured format. Imagine a well-organized spreadsheet with rows and columns. Each row is a record, and each column is a specific piece of information. This makes it easy to find and manage data. SQL databases are known for their strict structure, strong consistency, and the ability to handle complex queries. They are like well-organized libraries where books are sorted and easy to find. NoSQL stands for Not Only SQL. These databases are more like messy roommates compared to SQL's organized libraries. They can handle a variety of data types, including unstructured data like social media posts, emails, or videos. NoSQL databases are flexible, scalable, and faster for certain types of queries. They're great when you need to handle large volumes of data and when the data structure varies. The main difference between SQL and NoSQL databases are the structures, scalability, and the type of data they can handle best. SQL is structured and organized, while NoSQL is flexible and scalable. Which one to use? Choosing between SQL and NoSQL depends on the project's needs. If you need strict data integrity with complex queries, go for SQL. If you're dealing with huge volumes of diverse data or need to scale quickly, NoSQL might be the better choice. Many game studios prefer using NoSQL databases due to its scalability and the flexibility. Their databases can handle vast amounts of data and adapt to different data types. Perfect for dynamic game environments where player actions continually change the data landscape. The flexible schema-less nature of NoSQL databases like MongoDB provides significant advantages in game development. They allow rapid iteration and changes without the constraints of SQL structures fitting the dynamic nature of gaming. MongoDB specifically offers ease of use, scalability, and the ability to handle diverse data types, supporting the complex needs of modern games. Its online data housing saves significant resources and time during development. However, while MongoDB excels in performance and flexibility, be mindful of its approach to data consistency and the potential complexities in transactions, which might not suit every project. Additionally, consider operational cost and learning curve as your game scales. Despite these considerations, MongoDB's advantages often align well with the needs of game development, offering a robust solution for storing and managing game data. In conclusion, while there are various types of databases, NoSQL ones are often chosen by game developers for their scalability and flexibility, crucial attributes for the ever-evolving nature of games. Understanding databases and how they interact with your game through the APIs is fundamental in developing an engaging and responsive game experience. Alright, gamers and developers, that wraps up our journey through the interconnected world of game clients, REST APIs, and databases. I hope this video has illuminated how these critical pieces fit together to create a seamless and dynamic gaming experience. I want to extend a huge thank you for joining me today. If this video has helped you get a better grasp on game development's technical side, please consider liking, sharing, and subscribing for more content. Your support means that we can continue exploring fascinating topics like this together. Remember, game development is a journey full of learning and creativity. Whether you're a seasoned developer or just starting out, every bit of knowledge brings you one step closer to create that game of your dream. So keep experimenting, keep learning, and most importantly, keep gaming. Thank you for watching. I'll see you next time.